Everyone, today we will see a problem from oscillations. So the question goes as two particles P and Q start from origin and execute simple harmonic motion along x-axis with same amplitude but with different time periods, that is 3 second and 6 second respectively. The ratio of the velocities of P and Q when they meet is. So we know that displacement equation for a simple harmonic motion is x is equal to a sine omega t. So for particle P, the displacement equation would be xp is equal to a sine omega p into t, and for particle Q, this would be equal to a sine omega q into t, and t is the time when they meet. So we have to find the velocities of p and q when they meet. So we have to find the time when they meet. So now we have to find omega p and omega q. So omega p is equal to 2 pi by time period of p, that is 2 pi by time period of p is given as 3 seconds, so 2 pi by 3, and time period like the omega q would be equal to 2 pi by time period of q, so that would be equal to 2 pi by time period for q particle is 6 seconds, so that is 6. Now we just have to substitute here. Before substituting, let's find the velocity. Velocity would be the differentiation of the displacement. So Vp would be equal to a into sine omega t. Differentiation would give you cos omega t, that is cos omega p t into omega p. This is the chain rule for this differentiation, and for Vq is equal to a into cos omega qt into omega q. We know that omega p and omega q values, we just have to substitute here. A cos omega p is 2 pi by 3 into t into omega p, again 2 pi by 3 into so Vq would be a cos omega q. Cos omega q is 2 pi by 6 t into omega q, that is 2 pi by 6. Now we have to find the ratios of the velocities when they meet. So pay full attention here, because this is the trickiest part of this question. So let's say this is the mean position about their oscillations. So the particle P has a time period of 3 seconds. So the particle P would complete its oscillations in 3 seconds. One oscillation in 3 seconds. This is the first oscillation. In the next 3 seconds, it would have completed its another oscillation. That is its second oscillation. But the particle P, the particle Q would have completed its oscillation. It would have completed its one oscillation in 6 seconds. So when the particle P completes its two oscillation, particle Q would have completed only one of its oscillation. So there's a phase difference between them. So which is calculated as, for particle P, when the time t is 6 seconds, they would have particle P would have completed two oscillations. That is represented like this. The particle P would have completed its two of its oscillation, one oscillation and the next oscillation. But the particle P, the particle Q would have completed only one oscillations in 6 seconds. This is for Q. So the particle P, and this is the particle Q. So this is the particle Q. So there's a phase lag of 2 pi between them. So this part is 2 pi and this is Q. So there's a phase lag of 2 pi between both the particles. So now the initial phase of particle P is omega pt. That would be equal to the initial phase of Q particle plus 2 pi. Because there's a lag of 2 pi between them. So the initial phase would be equal to 2 pi plus the initial phase of Q. So we have already found omega p, that is 2 pi by 3 into t. So now we know that initial phase of P would be equal to initial phase of Q plus 2 pi, because there's a phase angle of 2 pi difference between them. We know that omega p is equal to 2 pi by 3. So 2 pi by 3 into t is equal to omega q is 2 pi by 6. So 2 pi by 6 into t plus 2 pi. Now if I bring this term here, so 2 pi by 3 t minus 2 pi by 6, 2 pi by 6t is equal to 2 pi. Now if I take 2 pi common, 1 by 3 minus 1 by 6 into t is equal to 2 pi. So this 2 pi would get cancelled. Now if I take LCM, 6 3s are 18, 6 minus 3 into t is equal to 1. So 3 by 18 t is equal to 1. So this gives t is equal to 18 by 3, which is t is equal to 6 seconds. So at time t is equal to 6 seconds, both the particles will meet. So now we have to find the ratios of the velocity ratios of the velocities when they meet. So Vp by Vq. So Vp is a cos 2 pi by 3 t into 2 pi by 3, and Vq is a cos 2 pi by 6 into t into 2 pi by 6. So Vp is 2 pi by 3 t into 2 pi by 3, and Vq is a cos 2 pi by 6 t into 2 pi by 6. Now this a would get cancelled because both of their amplitudes are same, and 2 pi would cancel. This 3 and 2, so 2 3s are 6. This 2 would give would go to numerator. So Vp by Vq is equal to 2 into, that is cos 2 pi by 3 t by cos 2 pi by 6 t. We know that t is equal to 6 seconds, so we just have to substitute cos 2 pi by 3 into 6 divided by cos 2 pi by 6 into 6. So if we cancel them, we would get 2 cos 2 to 4 4 pi by cos 2 pi. And we know that cos n pi is equal to 1 if n is even. If n is odd, cos n pi would be minus 1. So since it is both of them are even, they would have the same values, that 2 into 1 by 1. So Vp by Vq is 2 by 1. So Vp by Vq, I mean Vp is to Vq is equal to 2 is to 1. So the ratios of the velocities when they meet is 2 is to 1. So this is the answer. My hands now, you are the